Okay. Hi everyone. I know after lunch is not the best slot, but I don't make the schedule anyway. So hopefully my talk would be entertaining enough so you don't guys fall to sleep. I was going to introduce what Knative is, but kind of the video did that. So, but just to repeat, it's basically a serverless framework built on Kubernetes, right? Every second or third talk in the conference these days on Devops is on Kubernetes, and I do have some Kubernetes content also in my talk. Hopefully, I will try to be brief because I don't want to repeat what's already done. So let's start by Kubernetes, the de facto platform. Some people just make bold statements like Kubernetes has won. I don't know if I'd agree with that, but surely it's one of the most popular container orchestration system, right? You have pods, and it's just awesome. It was actually an open source version of a Google system called Borg. And what Kubernetes basically handles is it handles all the stuff like scheduling, scaling, load balancing, etc., etc. Stuff that you would need if you want to run containers on a large scale orchestration system. And there's a lot of big ecosystem surrounding Kubernetes, right? I have some details here. 5,000 contributors. It was written in Go. It's all open source. Many man years of effort, and if you look at the stats, you have a whole bunch of organizations that uses Kubernetes. So moving forward, let's talk about the state of affairs of we are right now in, right? DevOps as a discipline, right? It's a combination of developers and operators, and there's actually something very funny about this term DevOps, because developers and operators, their roles conflict with each other. For example, developers, right, they want to push in new features. Of course, they have to work, they'll test it and all those things, but they want to push new features as fast as possible. And operators tend to want the opposite, because their job is availability, right? They want availability and reliability. And if you have a high feature velocity, the chances that something would go wrong in your production environment is actually pretty high, because change is it's interesting, but it's dangerous in the sense it could break something. So there's a conflict, right? The developers want as many features as possible. The operators want as less feature velocity as possible. So how do you handle that? And a part of what DevOps is kind of balancing the two goals, right? At Google, we have a concept called error budget. And what it is every time you deploy a new change, you are allowed a certain downtime, you're allowed to make mistakes to a certain extent, right? So, and operators also understand that we are allowing you downtime, but we are allowing you to this particular extent only. So in a way, error budget is basically a maxima and a minima of how much downtime you're allowed, and you want to consume your error budget as wisely as possible. So stepping aside, coming back to Knative, developers would like to have serverless, right? We just want to run their applications. I don't want to deal with all the infrastructures and so on. And kind of what serverless does is, like serverless, you don't have to worry about all the mundane details about managing and so on. So serverless is great for productivity. Operators, on the other hand, they want a great orchestration system for microservices. Kubernetes is one. Being Google, I'll emphasize JKE, but I'm sure AKS and AWS would have equally good orchestration systems. So they would want to, have something like JKE or a managed service. Kubernetes is kind of not the right abstraction for developers, but it's a wonderful abstraction for operators. And then we enter into this world of conflict, right? And that's what Knative, as I'll explain later on, Knative kind of resolves. It wants to keep the developers happy, but it also wants to keep the operators happy. How do we do that? So let's actually move to the serverless, right? So what are the characteristics of serverless? Obviously, you have servers, but you just don't manage, hence the term serverless. Like a lot of people think serverless means no servers. Obviously, that's not true. It's obviously event driven, so asynchronous models, you have events and you communicate, you have different connectors or bindings to different kind of event. In Azure, you could probably connect to something like the message bus on Azure. Google has the same, Cloud Pub Sub, so on, so on. So you have all these different bindings for all these functions, self-executing code running on these containers, right? The beautiful characteristics of serverless is that it's a pay-as-you-go model. And not very common, but ideally you want to have portable model. The existing serverless offerings from major cloud provider actually fall short on that. They are not exactly portable. I guess you can just, there are workarounds and hacks to do that with their own pros and cons, but the problem with the current offerings of serverless is you can't just, take the code on AWS and make it run in, GCS or Azure. But ideally, you want portability because you don't want to have a vendor lock-in. So, having said something about serverless and desired characteristics of serverless, let's actually move to the actual Kubernetes, Knative, sorry. Knative, it's pronounced as Knative. It's basically a native platform for Kubernetes. So it's a Kubernetes-based platform, as I mentioned, for building blocks of serverless. It actually has all these difficult but boring parts that it already has. It has basically Knative project. It's set of primitives. It has three main components, and I'm going to go into details of each one of them. But basically, very briefly, there is build, there is eventing or events, and there's serving, right? And if you go to the repository github.com, the Knative, you would actually have these three, and you have several other repositories. All of it is being open sourced. A test infra and so on for testing, which mostly for maintainers of Knative, not so much for consumers. But you have these build, eventing, and serving as three separate repos. And it's kind of implements learning from a lot of industry partners, Google being one of them. We have a bunch of other people who collaborate. In fact, every week we have a meeting with all our industrial partners. I'll give a list of all the partners who are actively involved with the Knative project. But it implements learning from, Google operates services at a very high scale globally. So it implements all the best practices. It has all the ingredients for serverless. And it's kind of a modern framework. So it takes into account all the modern development practices. So like I mentioned, operators, they love Kubernetes, right? Because it abstracts away all the operational complexity, and it's kind of, I don't know what the AWS service for Kubernetes is, but I know Azure has AKS, Azure Kubernetes Service. Google obviously has GKE, Google Kubernetes Engine. So it's kind of universal. So you have a sort of portability, right? You can just, and it's very extensible. Quoting Kelsey Hightower, who once said that Kubernetes is a platform for building platforms, basically. And Knative is one such platform. And on top of Knative, there are other platforms. There's a lot of platforms here. But yeah, so for operator, he gets all the benefits of Knative via the Kubernetes, right? So they can deploy and manage. And it's kind of, like I said, platform, all the major cloud vendors support it pretty nice. For a developer, the different story, like I mentioned, developer wants to write code. So they don't want to deal with all these management tasks. A list of them is here, build the image and upload, etc., right? They want to kind of automate. And this is what a Knative actually does. More specifically, the build component of Knative that I'm going to talk a little later, that actually does all these. It has standard build templates that you can download and build from your repository, and you can upload it. So developers don't want to do that. And Knative can automate a lot of this stuff. So these are the major organizations that are involved with Knative, Google being one, obviously, Pivotal, SAP, Red Hat, and IBM. I'll have some of the examples for that, but every week we guys sync up and we talk about all the features that we want, and we basically work in sync. But it's open source, so anybody can actually contribute to it. We accept PR, and towards the end, I'll give. We have like a Slack channel, so anybody can actually join and talk to the maintainers and developers directly. I'll give the details of the Slack channel towards the end of the talk. So moving on, I would want to go into the Knative stack. How does the Knative stack looks like? The base is Kubernetes, obviously. And I should mention that, I mean, this is the standard stack, but you can kind of customize it. If you don't want to use Istio, which is the default service mesh, you can actually replace it with something else. So the standard stack would look like this. You would have Kubernetes, right? Then we have Istio, which is the service mesh. And then you have the three main primitives of Knative. So you have build, serving, and eventing. And on top of it, these are the extra platforms that are actually built on top. You have like SAP, Kaima, and Pivotal Riff, and whole bunch of it, and you can build your own platform on top of it. So that's how a typical Knative stack would look like. But obviously, you can customize it. With me, I have some customer testimonials. So here's one from Snap, and they talk about how they accelerate enterprise-grade serverless event-based systems. You can read about the details. I'm not going to read what's already on the slide. But SAP being a major partner, the other partner is basically IBM Cloud. They created the OpenWhisk, and they actually bring serverless much to a wider applications and developers. So that's the IBM fellow and CTO quoting about Knative. We also have Red Hat as our partner. So this is what they have to say about Knative. It's a common building block for serverless. We also have T-Mobile, which is also actually based in Seattle, where I'm from. So, this is what he has to say. It just works brilliantly with each other. So let's actually move on to the functionality of Knative. What does Knative actually provides you? So it's a very typical, serverless kind of framework. You obviously have a pay-as-you-go, so whenever you have a workload, it would wake up. So that's how it implements the pay-as-you-go model. It can scale 0 pod to theoretically infinite pods. Hopefully you never need it, otherwise you'll get a big bill. So, but sure, it is scalable. It turns developers and app function into URLs. It has a lot of like Istio and other, because of all the service mesh it has a lot of telemetry and metrics collection, all that by default built in. But these are all like pluggable components, right? So if you want to replace it with your own framework for collecting metrics, you could actually do that. And I'll show a detailed example of how it can split traffic. But it actually can. It has a concept of configuration, so it can create different it's an immutable infrastructure, right? So every iteration you basically have different configurations, and then you can bifurcate the traffic. I want 25% of the traffic to go to this configuration. I want 75% to that. I would have an example somewhere in the middle. And it has all the eventing system with configuration sources, so you can connect to whatever source you want. Being open source, you have a rich ecosystem of all the sources and triggers and so on. So I'm going to go into details of each one of these components. So I'll start with serving, right? Serving basically deals with all the routing of the traffic. So one of the benefits of serving is that it can, seamlessly scale up and scale down. In the next slide, I'll show an example of what it is, but basically it can split the traffic between the revisions. I'll show how it's done. And it integrates with the service mesh, and it's quite pluggable. Initially, when we started, we actually had one Knative repository. And later on, we decided to split into eventing build and the third one, which would be eventing build, which was serving. Yeah, sorry. These three ones separately, because that was a kind of forcing function. When you have one repo, you kind of have like, I want to use version 1 of build with version 1 of serving with version 1 of eventing. But we wanted a pluggable system, so we don't want to force you in saying you want to use version across the board. I can use version 1 of eventing with version 2 of build with version 3 of let's say serving. So kind of it's a pluggable system, right? It can be it has a lot of benefits, like autoscaler can tune and swap for custom code. So going into serving, right? Service is a function, you have a route, and then you create a configuration, and every change that you make would create a new revision. The internet is a issue, but I actually had a demo where I had loads and loads of YAML file connecting to GK. Unfortunately, I can't do that, but I would have some links towards the end, so you could actually play your own. There's tons of on YouTube. If you do, you'll have tons of demo on how it's actually done. But basically, Knative primitives, it has a clear separation of concern, right? So you will have a configuration. Every revision creates a new configuration. It follows the 12-factor model, and then you can it's immutable. One revision is obviously immutable, and then you can route the traffic accordingly. So with YAML configuration, you can say 25% of it would go to revision 1, 50% would go to revision 2, 25, etc., etc. How you want to route your traffic. So that's serving. The second component here is eventing. So serverless is basically an event-driven kind of framework. You consume and you generate events, so there's a loosely coupled model, right? Kind of similar to microservices. In fact, this is actually an interesting topic, that how to implement microservices using a lot of serverless. You could actually do that. There are different pros and cons of doing it. But coming back, it's like an event-driven model, right? So you have different sources and flow, and eventing kind of controls all that. So scales from few events to live streams, and it has like pipelines to connect to your existing systems. So, yeah, this is a kind of a model of eventing. You have the source, you have the channel, and you have different services that kind of consumes these. And here you have primarily 3 eventing objects. So let me actually get into what those 3 eventing object is. Now I do want to mention that Knative is actually a very active project. Right now the latest release that we have is 0.04, and we kind of follow like a dot release every month. So in April middle we would have a 0.5, but the point is we don't really have a 1.0, so a lot of the stuff changes quite often. So you have to be just careful that it's a volatile development area. But anyhow, coming back to eventing, you have event sources, right? And then you have a channel, obviously, the pipelines, and finally you have subscription, which is all the configuration that you have. So there are event types, event source, flow. You can see that from the diagram. So that's eventing. Let's talk about build, which is the third and the final component, right? Build is how you would basically take your code from the repository and build it to a container. There are a lot of build templates. Towards the end, I have a link on GitHub which actually shows you all the different build templates. So in most of the cases, you can take an existing template and just use it. Obviously, it's a YAML file. You can configure it and customize it to your own need, and it handles all the service account and auth with Docker Hub, etc. And what it basically does, it allows you to build from source code to container images on repositories, right? So a build step can have multiple steps, and you can push it to different kind of registries. A build runs in kind of containers and clusters, so you don't really need Docker locally. You have something called build on the cluster. So the way the Knative value proposition, the way it is it's a one-step deploy, right? It has a build with config and code, and then you have source to container safely in your cluster. Like any other serverless framework, it has auto scale. You can scale from all the way to 0 to theoretical infinite limit, auto scaling, and then you manage all the workloads. So yeah, Knative, these are some of the links. That's the Slack channel, Knative Slack demo, and there are docs right now. That's github.com/knative/doc. Now, there was a website, I think it's operational now, but if you go to knative.dev, they are basically moving all the docs out of GitHub, and it has its own website, knative.dev. I'm pretty sure it's operational, but it's an alpha version right now, and it links to all the source code. then if you have if you need anything else, you have my Twitter handle. Please free to contact me. Now I did had a demo, but because of the internet problems, I can't actually show the demo, and I can't even go to the links. I'm apologize for that because I wanted to show what the link was. So yeah, I'm pretty much done. I'm up for questions.